Hi again, pre-calcers. Time for lesson 9.6, the complex plane and polar form. So now we're going to try to merge together the two key ideas so far this chapter. One being polar form, that's the new thing, and now we're going to merge that with complex numbers. So you can see this graph I have here. This is the graph now that we're going to be graphing polar coordinates, but not just any coordinates, ones now that are complex numbers. So traditionally then the x-axis we'll call the real axis, and the y-axis then is the imaginary axis. So for instance, that particular point that you see graphed right there, we would graph that as 3 because it's over 3 on the x-axis and up 5 on the y-axis, so to speak, but we do put an I in there. So that particular point right there is the point 3 plus 5i. Now, we would call this rectangular coordinates because essentially it has an x and a y value, even though in this case we would call them the real part and the imaginary part, but those are rectangular. Now, in this particular coordinate, the r value is the same as the r value that we have seen before. So the r value would be from here to here. So we could calculate that. In this case, r would be the square root of 3 squared plus 5 squared. So that's 25 plus 9, which is 34. So it would be the square root of 34. That's the r value. Now another name for r then is the absolute value or the modulus. Again, we won't use those terms very much, but in case you hear them, that's what it would be. Theta then, and of course our theta would be this angle right in here. We could term that the amplitude or the argument. In this case, a little tricky to get that. We'd have to do the inverse tangent of 5/3 to get that angle. That would be the amplitude or the argument. Moving on here now, here's a new form now for a complex number that's in polar form. So this is the official name, polar form, or sometimes we will most often refer to this as trigonometric form. R cosine theta plus I sine theta. And a lot of times we'll just abbreviate it as R cis and then whatever the angle is. So we don't have to write out cosine plus I sine. So we have various names for this, and sometimes they're interchangeable. This is still polar form, but now we have complex numbers. So trigonometric is one name, polar complex form is another, but we'll get the feel for it. Once again, a lot of times we just like to convert from rectangular to polar and vice versa. So for instance, in this particular case here, if I have 4 plus 5i, I prefer to kind of draw this out a little bit. So I'd be going over 4 and up 5 like this. So I could draw my little triangle like this, 4 and 5. Again, what I need to find, if I'm going to put this in polar form, I need to know this r value and this theta value. Okay, so r is not too bad. R is, this is not a familiar right triangle, so we would have to say that it's going to be 4 squared plus 5 squared and the square root of that. In this case, that will be the square root of 16 plus 25, which I think is 41, so there's your r value. Now theta, again, the way to figure that out is probably through an inverse formula here, so I have to use the inverse tangent, and tangent is opposite over adjacent, so I have to use 5/4 in this case. And so it looks like my answer is going to be, I guess I have to dig out a calculator here since I don't know that right offhand. I'm just going to go in degrees here, so I'll make sure I'm in degree mode. And if I do the inverse tangent of 5/4, I come up with about 51 degrees. So theta is going to be 51. So if I'm actually writing this in polar form, or trigonometric form, then it would be, I don't know where I have room to write this, but I'll do it up here, I guess. So it would be the square root of 41, and then cosine plus I sine, but I'm just going to do the cis 51 degrees. So that would be the polar form or the trigonometric form of that. Now, next one's maybe a little trickier. Negative 2i. Now, how can I make a triangle out of that, or where would this even be? Well, negative 2i would be the point, which is going to be right about here. Remember, the I-axis is kind of like the Y-axis. And as far as the R value, always the distance from the origin, so that's going to be 2. The angle would swing right around like this, so my angle is actually going to be 270, or 3 pi over 2. So if I write this in polar form, it would be 2 cis 270. So you don't always have to draw a triangle to be able to sketch these out, but especially the ones that are right on a special quadrant or right on an axis are a little bit easier to figure out like that. All right, next it says graph and express in rectangular form. So here now we're going vice versa, and now I have my trigonometric form. I'm going to get it back in rectangular form. A couple different ways you can do it. One pretty nice way is just by substituting. So the cosine of 2 pi over 3, if you dig out your circle chart and think of where that is, that's 120 degrees. If you think about the cosine of that, that's just going to be negative 1/2. The sine of that at 2 pi over 3, that's the square root of 3 over 2. And if I distribute this 4 to it, I get negative 2 plus 2 times the square root of 3. And I do still need that I in there because it is a complex number. And if I was going to graph this, if I did my scale different, if my scale was going by 2s, it would be graphed right at that point right there. So that's a fairly easy type of problem to do. All right, and next, here's our 6 cis 180, means the exact same thing. If I graph that, 6, again, if I go by a scale of 2, it's going to be way over here. And so how would I write this as a polar coordinate? Or excuse me, as a rectangular coordinate? Well, I need an x and a y, so to speak. Clearly my x value would be 6, but I would probably write that as negative 6. My y value, or I value here, would simply be 0. So I could write it like that, or I could write it as negative 6 plus 0i, or just plain negative 6. All those are pretty comparable. So not too much different than what we did before in converting from polar to rectangular. Just now our polar and rectangular have a bit of a twist because they are complex numbers. All right, so you get on these polar coordinates, so it's time to take a little break, a little breather, and we'll see you in class tomorrow. Farewell.